Section 2 is going to be the circle part of this whole thing. This unit is really going to be about volume and surface area. And so the first two sections, section 1 was finding area of polygons. Section 2 is going to be circles. And then what's going to be used later on in sections 3, 4, 5, and 6 is how to find surface area and volume of particular three-dimensional shapes. So what we're going to use from circles, this is really what Unit 8 is all about, which we're skipping. You need to make sure you know the formula for the area of a circle. Notice I've been giving you some formulas. Those formulas you're expected to know. You will not get a formula sheet for this unit, not for honor students. Honor students, we expect you to know what the formulas are during this unit. The area of a circle is pi times r squared. The circumference of a circle, you can use two things, 2 pi r or pi times d. This is used when you're given a radius. This is used when you're given a diameter. Remember, twice the radius is the same thing as the diameter, so either formula is correct. The hard part is to remember which one to use when what you're given. Some people will use, it's 2 pi r, and then it's you're really supposed to use the diameter formula. Arcs and sectors are created from part of a circle. So a lot of times this unit, we won't just deal with a whole circle. What we're going to be dealing with, so if I think of a whole circle like this, what we're going to be dealing with is part of a circle. So if I'm thinking of a sector or an arc length, we may not be talking about the whole thing. We may be talking about just a piece of it. So if I go from here all the way around the circle, that's 360 degrees. That's important for you to know. Arcs, we're talking about this distance. This is an arc length. That's an arc length right there. The measure of the arc has this little thing over the AB. When you write it, AB, you just put a little arc over the top of it. It kind of looks pointy, but it's supposed to be just an arc as you go over the AB. And that would mean that this arc length is however many degrees this is what that angle is right there. For example, this might be 70 degrees. That means this angle here. Did not mean to do that. That means this angle here is 70 degrees as well. That's how much of the whole circle we have. So sometimes we're going to be dealing with half circles or a quarter of the circles or what have you. So if you want to figure out what percent of the whole circle it is, you just take however many degrees you have and you divide it by 360. That's the percent of the whole circle. Which means if I wanted to figure out how long this was and I want to find its arc length, all I really have to do is know how many degrees out of 360 times by the circumference of the whole circle. This will find the percentage of the whole circle, the percentage of the circumference, or the percentage of the circumference when you're given a diameter. That's how you're going to find this distance. This is arc length. Whereas if I wanted to find the area of the sector or the filled in distance, you're going to take the percentage times by pi r squared. Both of these formulas are somewhat common sense if you know how to get that percentage. The last thing that we're going to talk about is the segment of a circle. The segment area. Sometimes we're going to draw this line from here to here. And we're going to fill this stuff in. And we're going to have to figure out what that area is, either on this side or the filled in area. And when you're doing that, you're going to take that sector area and you're going to subtract the area of the triangle to figure out what the segment of the circle is. And I'll show you an example of that down below. I have some examples for you to look at. Number 5, number 8, 15, and 16, and 19. I have 5 examples for you to do. If you would like to do them in your notes, you are welcome to do so. This is number 5. Number 5 says, find the length of each darkened arc. It's very hard to see on your worksheets. But I will highlight what is darkened so you can start to recognize it, but it is darker, just barely. This part here is darker than the rest. That's what we're trying to find. Find the length of each darkened arc. Leave your answer in terms of pi. So this is not shaded. We're looking for a distance. When you're thinking of a distance, you need to be thinking 2 pi r or pi times d. Is this 15 a d or an r? If you know, tell the person you're sitting next to. I would put the letter D next to that, 15, because it is the diameter. Whenever it's written right next to the center, you need to assume it's the full distance. That means that a full circumference of 2 pi r doesn't make sense. Pi times d makes a whole lot more sense here. 15 pi is the circumference of the whole circle. But we don't want the whole part, do we? We want to know how much is this compared to the whole thing. So what we'll do is we're going to take the measure of the arc, 120 degrees, out of how many degrees? And we're going to multiply that by 15 pi. This will give us the arc length. This will give you your percentage of the whole circumference. Now you should get used to doing some fraction stuff, and so you can use a calculator for this, but for some of you, let's say you don't need the calculator, you start doing stuff in your head. 0 goes into 0, 12 goes into 36. Whoa. 3 times. And so if I know that that goes into 3 times in the denominator, 3 goes into 15 5 times, and I have to leave my answer in terms of pi, then my answer is 5 pi feet long. 5 pi feet long. That's the distance around that arc. We'll do another one. Number 8. This one gets a little bit harder. A bicycle tire has a diameter of 12 inches. How many inches will the bike travel after 100 revolutions of the wheel? Round your answer to the nearest inch. That's a great question because that's very real life. During Christmas, one of my gifts to my son was it's called a computer, but it basically reads when you're riding your bicycle, how fast is it going? So I showed him that you have to set the computer to a certain diameter of the tire, because if you have that set wrong, then all your calculations are done incorrectly with the computer. And the computer reads how many times does the wheel go around, and it tells you how fast you're going. You can have that on your bicycle. Very, very little cheap, fun gift for Christmas is what I gave him. A bicycle tire has a diameter of 21 inches. 21 inches. Here's the tire. The diameter is 21 inches. So the basic thing that I need to think of is, how far does it travel in 1 revolution? How's the distance per revolution? How can I find the distance from here all the way around? That is the circumference. The formula, since I'm given a diameter, I'm going to put a d next to this, is pi times d. So I know that pi times the diameter is the distance every revolution for one revolution. How many inches, and this is how many inches, distance in inches, will the bike travel after 100 revolutions of the wheel? So now if I want to find the distance, I'm going to multiply this by 100 revolutions. The revolutions would cancel, and I have 21, have a good day, pi times 100. Two, 1, 0, 0 pi inches will be 100 revolutions, but it doesn't say leave it in terms of pi. It says round your answer to the nearest inch. 2100. I use the pi button, which is right above this times 10 key, so I have to press shift pi. It shows it right here. Press equals. Your answer is in terms of pi if you want to leave it in terms of pi, but there's a switch it to a decimal button called SD, standard to decimal, and it can toggle between pi in terms of pi or the decimal equivalent. So I'm going to do 6597 to the nearest inch, nearest whole number, inch. That's how many inches it travels. Inches aren't really used on those computers. They usually, you want it either in miles per hour or kilometers per hour, so their computer would actually compute, okay, this many inches, and then it converts it to miles per hour for you, just depending on what your settings are. Kind of neat. We could do the math behind it, but we're not going to because it doesn't ask us to. Number 15. Find the area of each shaded sector of a circle. Leave your answer in terms of pi. Now we're finding area. Is this a diameter or is this a radius? Put the letter next to it. And then when we're dealing with area, we're using the formula pi r squared. What does that mean you have to do for this problem when you're plugging in the radius? What do I have to do first? What is r? You might have to cut it in half. Pi times 12 squared is the area of the whole shape. But that is not what we're going to find. We only want the shaded region. And the easiest way to do that is to do the percentage. From here to here is not 120 degrees. This is 120. How much is the top half of the circle? How many degrees is that?
80.
So if we have 180 plus this 120, how many degrees is that? Out of how many? That will tell us the percentage of this circle, the percentage of the whole area we need. We need to leave our answer in terms of pi. Our calculators pretty much do that. But let's say I wanted to do it by hand, just because. That goes into there. Divide by 3. Divide by 2. Pi times 144. Divide by 2. Divide by 2. Does 3 go into there? 1. 3 goes into 72. 2 times. 1 left over. 4 goes in 24. 5 times 24. 20. 120. My guess. 120 pi meters squared as my answer. Let me double check with my calculator. 300 over 360 times pi times 12 squared. Oh, it's kind of nice when you can do it by hand just as fast as how you would do it without. There you go. Number 16. I have 2 more examples, so let me quicken this up a little bit. This is where it gets harder. Find the area of each shaded segment. There's no formula to find this particular thing. So what we are going to do is we're going to go over here and we're going to find this sector area, and then we're going to subtract the area of the triangle. So that's what we're doing with this last formula. What does that mean? That means this on number 16. I'm going to find the area of this whole thing, of the whole Trivial Pursuit piece, the whole sector area. I'm going to find this first. And then what I'm going to do is I'm going to subtract the area of this isosceles triangle. And that will leave me with that area right there. So to figure out what this is, how many degrees out of 360? Times pi. What's the radius? Radius squared. This gives me 120 degrees out of 360 times pi r squared. It's going to give me the area of that whole sector. I like the word sector. It reminds me of discus and shot put. In track and field, what they throw, the place where it has to land is called the sector because it's a geometry word that means part of a whole circle. If you didn't know that, welcome to Track and Field 101. So now we have the whole sector. Now I have to figure out what this area of the triangle is, and this is where you're going to use what you learned before. Radius is 2. Guess what this radius is on this side? 2. 120 degrees. Guess what this whole thing is? 120 degrees. Way back when we did constructions, I don't know if you know this, but if I draw a line from, if it'll let me draw, from here perpendicular, that's going to cut it directly into 2 equal pieces. So how do I find the area of the triangle? I'm going to use 1/2 the base times the height. But you're only given this distance, yes, but because this is 120 and we cut it directly in half, guess what's going to come into play again that we use all the time in with triangles? 30, 60, 90. What does that mean? That means across from the 30 is S. Across from the 90 is 2S. And down here is S root 3. If the radius is 2S, then that means S has to be a distance of 1. That means your denominator, or not denominator, this part of the base is 1 root 3. Well, that's not the base yet because we have 1 root 3 on this side and we have 1 root 3 on this side. Now I can go into my formula. The base is 1 root 3 plus another root 3. 2 root 3. The height is equal to 1. And then this minus this will give you the area of the smaller piece. What I like to do is I like to write down everything before I even touch my calculator. I hope that you will start doing that as well. And then what I like to do before I touch my calculator is have an idea, okay, what is this going to be? This will be 1/3 times by 4 pi. That's 4 pi over 3. Half of 2 is root 3 times 1 is root 3. So I kind of have an idea of what my answer is. I'm thinking it's going to be 4 pi over 3 minus root 3, but I need to round my answer to the nearest tenth. So I'm going to use a calculator. Now, I'm thinking about plugging this in, but instead I'm going to go right back to here in case I made a mistake. 120, 360, times pi times 2 squared minus 0.5 times 2 root 3 times by 1. I don't need to write times by 1. So there's everything I've plugged in. Let me verify. Did I punch it in as I have? And I'm getting round to the nearest tenth. 5 or higher, I round that to a 0.5 meters squared. Now, just to see if my math is correct, I'm going to type in 4 pi divided by 3 minus root 3. Oh no, that did not go well. 4 pi divided by 3 minus root 3. Same answer. Just wanted to check. Last example. Find the area of the shaded region. This one's kind of opposite of what we did before. And so you can do it in a variety of ways, but what I want you to do is just use your common sense as you're figuring things out. For me, it will be easier if I figure out what this area is and I add that area. So what I'm going to do is I'm going to figure out the area of 3/4 of this circle, and I'm going to add the area, how on earth am I doing that, of the triangle. You can decide however you want to do it. So I know that that is 90 degrees. 90 plus 270 is 360. So I know how many degrees this is. This is 270 degrees out of 360, which your common sense might actually take over here and say, why are you doing that, Mr. Promo? I'm just showing you that that's what you could do, because this is how much of the circle? 3/4. If you don't see that, quarter, think of it like that. 3/4 of how much? Of pi r squared. Pi, what's the radius? Squared. Plus 1/2 the base times the height, and those need to be perpendicular to each other. What is my base? What is my height? I'm going to go 1/2 goes into 12 6 times, plus 6 times 12. I'm going to work that out. 6 times 12 is 72. 4 goes into 144. 36 times. 3 times 36, 18, 9, 108 pi plus 72. Leave your answer in terms of pi and in simplest radical form. There is my answer. 108 pi plus 72. And I'm curious if I did my math right, so I'm going to double check on my calculator. 270. 360 times pi times 12 squared. I'm just going to press equals right there. 108 pi. Got that. 0.5 times 12 times 12. 72. I can double check. That is correct. We'll stop your notes right there.